Okay. So today we are going to talk about NLP. So today's topic is pretty basic. Everyone know what is NLP, right? NLP. So let me ask you, what is the full form of NLP? Anyone?
Natural programming language.
Yeah, that's right. So NLP is also known as natural language processing, not programming language, but natural language processing. Okay. So, what does it do? It is a technology that allows machine to understand and process and generate human language. Okay, what it is? It is a technology that allows machine to understand and process and generate human languages. Earlier, NLP models relied on the rules and dictionaries, but the modern AI use deep learning in it. Okay, so today we will explore the evolution of NLP and how NLP is used in ChatGPT and other things, and how ChatGPT came into existence. So what does actually NLP contains? NLP contains like text input and data collection, text process, text representation, feature selection, modeling selection and training, model deployment and interface, equivalation and optimization of the text, and improvements. Okay, so NLP is used in chatbots, search engine, speech recognition, and translation tools. So, as I have said you, so can anyone tell me what are the different kind of chatbots except ChatGPT? Yeah, guys, can anyone tell me?
Deep AI.
Sorry,
Deep AI.
the deep AI. Okay, what else?
DeepSeek.
I said chatbot.
Copilot.
Okay, what else? Okay, so we can say Siri, we can say Alexa. Okay, we are using Siri and Alexa, right? So these are chatbots. Can anyone tell me different types of search engines? Like different search engines that use NLP? Okay, okay, Google, yeah, Google and Bing is one of them. Okay, yeah, Chrome is similar. Like, so can anyone say what are the speech recognition tools that use NLP? I repeat, speech recognition or speech, yeah, or text summarization tools. We use speech recognition day to day, right? Anyone? Alexa, okay. Now series also contain a speech recognition and what? Google Assistant. Any more? Okay, while chatting, we use a voice typing, right? We can chat through our voice. So that is also a speech recognition tool that use NLP. So other than NLP, let's talk about word embedding and word to vec. So the basic question is how do computer understand words? Anyone? How do a computer can understand a word? Okay.
Through binary language.
Yeah, what is the binary language? It is 1 and
0 and
0.
1.
Okay. Yeah, right. So, what does computer do? It converts the letter or the word into binary languages. Okay. So, traditional NLP models treated words as separate symbols, like IDs. For an example, apple might be represented as 0100, or banana can be represented as 0010, like that. Okay, but this method doesn't capture the meaning of the word. Okay, like if you write apple, it will understand what like it is known as apple, but what is the actual meaning of apple? Like apple is a fruit or what is it? Okay, I hope you understand, right? Okay, so like in 2013 actually, word to vec changed everything by converting words into meaningful word embedding. Can anyone tell me what is word embeddings? uh, Let me repeat, word embeddings. Anyone? I just told you about word embedding just few minutes ago. Hello, I am audible?
Yes, ma'am.
Yeah, so what is word embedding? Okay, so basically, word embedding is a technique in natural language processing that represent word as binary or as vectors. Yeah, word as numbers, right? So when we like I have told before that when it comes to the before 2013, like before the word to vec was introduced to the world, we the words were converted into binaries, which don't have any meaning. Okay, they were only just word. But after 2013, word to vec changed everything and converted word into meaningful word embeddings, and mathematically a mathematical representation of words in a multi-dimensional space. Okay, now similar words are placed close to each other in this space. Like if a space contain, like if there is a multi-dimensional space, and so for example you take two words, one is king and one is queen. So we know king is a male version, queen is a female version, so they will go together in a 2D space. Okay. So there are two main ways in word to vec work. How word to vec works. One is a SIBO and one is a skip-gram model. Okay. When it comes, what is the full form of SIBO? It is continuous bag of words. Okay. It predicts a word that based on surrounding words. For an example, when we text in WhatsApp, we see suggestions of words coming out, right? So what it does, it predicts a word based on the surrounding of the word. I hope you understand till this, right? Yeah. So let's talk about skip gram model. What it does, it predicts surrounding words based on a given word. Okay, like if you give mango, so the model will tell you that mangoes are yellow in color, right? Like that. Like what happened in cowboy, I'm telling you, Sibo, uh, what the word, it predicts a single word seeing the surrounding. For an example, a fruit that is yellow in color, it will say mango, banana, anything, right? But when we tell about a skip gram model, what it does, if we tell us about mango, like we give the input as mango, it will tell us a fruit that is yellow in color, grows in summer seasons. Okay, so this was a breakthrough how a word to vec works. uh, let's talk about the limitations. Okay, so word to vec, it couldn't handle sentence, like it couldn't handle a big sentence. Okay, so for that we use RNN and LSTM. So anyone can tell me what is RNN? I have told you several times, I guess. Anyone? Just what is RNN?
Recurrent neural network.
Yeah, right. Recurrent neutral. What is does? Like what RNN does?
Convert a sequential data input into specific sequential output.
Okay. Hmm. That's a correct answer, but what else can it do? Like the main motto of RNN. Why did I use speech recognition? Yeah, I'm not telling about the like specification, like features and all. I'm telling about what RNN does, like how this speech recognition and all works while RNN. Okay, so what RNN does is it remembers the previous word, right? Like that's the reason it is used in a big sentence. For an example, I am going to school. So it will remember school, but the previous word is going, right? Or the previous word would be to. So I am going to school. So it will remember the to, so it will remember the whole sentence and it will remember the whole meaning of the sentence. Whereas in word to vec, it will only remember the meaning of one word. Okay. It will not remember the whole word. Like it can remember, but there are limitations of sentences. Like it can't remember a long sentence. So the RNN was like introduced. Let me share you the diagram of all the things. Let me share you from the first. Wait a second. Yeah, I hope this is visible, right? This is visible, right? Hello, hello. Okay, yeah. So this is the diagram how NLP works. Okay. So first is text input and data collection. Then it comes to text processing. Then it comes to text representation. Then feature selection. Then model selections and training. Model development and interface. Evaluation and optimization. Then improvements. Can anyone tell me what is an interface? Like I'm just asking you the basic question right now. What is interface? You can give any example if you want. Okay, so interface is a, you can say, UI. We can see it, right? We can, we that is not the back end, but it is the front end, front like a web page. It has an interface. Okay. So the next thing is this one. So as I have told you, yeah, as I have told you, these all things like the emojis and yeah, API. Okay. Yeah. So these all words and these all emojis is are converted into what? Binary numbers, right? So this is what wo word embedding means. Now let's come to this. This looks tough, right? Isn't it? Okay, so can anyone tell me by any chance if you know? Just I'm asking a question. Like what is this? Anyone? Any idea about what we're going to tell on this topic? Okay, so this is a continuous bag of words, right? So we are giving continuous words, okay? And what we are getting? A single word that is predicted from this continuous word, like what will come after this. So what is a SIBO? It is a natural network-based model used in NLP to predict a targeted word using context words. Like these are the context words. This is the targeted word. Okay. So the input layer contains multiple context, or we can say multiple words. Each word represent as one hot encode vector. Okay. This word is represented as each word is represented as one hot encode vector. The hidden layer, which is the middle layer, is the vector from the input layer and averaged and passed through a single hidden layer. Okay, so this is usually without an activation. Okay, so the next thing is the output layer. Okay, the output layer contains that the model predicts the targeted word. The the output is probability distribution over the vocabulary where the highest probability corresponds to the predicted word. For an example, the, like I have given here the, here cat, here on, here the, okay, the cat on the, like I have given those words. So what can be? It can be any context, but basically it can be either a mat or on the chair, right? So this will predict the word. So why SIBO is important? It captures cinematic relationship between words. It reduces dimensionality by learning word embedding, and it is the faster and more efficient than other NLP models. Can anyone tell me what are the other NLP models? Anyone? Other NLP models?
Linear regression model.
Um, no, that is not an NLP model. What are the other NLP models? Anyone? Okay, tokenization. Okay. Mm. Okay, there are transformer based models. Yeah, transformer is one of them. That's right. So under transformers, we can get BERT, we can get robot, we can get XLNet. Okay, we can get T5. So these are all like GPTs. Okay, and And other notable NLP models are like we can say Bart, we can say Albert, we can say FanTB. Okay, we can say Clip, Flamingo. So these are all NLP models. Okay, so as I have told you, yeah, BERT is one of them. Okay, so the summary of this SIBO, this diagram is the SIBO predicts a target word given surrounding words. I repeat this line. The SIBO predict what it predicts. It predicts a targeted word given surrounding words. It uses one hot encoding, a hidden layer, and a soft max output layer. It is widely used for word embeddings in NLP applications like search engines and chatbots. Right? I hope you understand this much. Do you have any doubt till here? Or shall we go to the next diagram? Okay. Like, do you have any doubt? I hope somebody, I just saw somebody just wrote yes, I guess. Okay, like Pankaj, do you have any doubt? Hello. Okay, okay, okay. So, we have just learned about SIBO. What was the other one? Can anyone tell me? What was the other one? Guys, can anyone tell me what was the other one? It was the skipgram. Okay. So it is a key technique used in Word2Vec for learning word embeddings. So skipgram is a neural network based model that predicts context words given a targeted word. Like it is the opposite of SIBO. So here you as you can see the input layer, okay, it contains a single targeted word. For an example, let's take this as a mat. Okay, for an example, let's take the word mat as an input. Okay, the hidden layer, or we can say the projection layer, contains targeted word. The targeted word is passed through it. Okay, like it is a single hidden layer. The hidden layer learns a dense word embedding, which is we can say a vector representation of words. And then what we get from the output layer, the model predicts multiple context words that are like to appear near the targeted word. For an example, when it comes to you a mat, what next? Anyone just write it down. What next word can it be? Like what do you think it could be? You just need to guess a word, just a word. Okay. Okay, sheet. Okay, very nice. Mat sheet would be the word. So similarly, it will as I guess. Okay, yeah. So uh, as Paras said, it can be a sheet, it can be a table, or it could be a cat. Like that, it will predict all types of word, and what it will then each output is a probability distribution over the vocabulary. The word with the highest probability are chosen as the predicted context word. Okay, so like for an example, when we write hello, okay, nowadays if you are using chat gpt frequently, you will see then when we type just a word, many suggestions will come out. For an example, when we type just a simple word is what, so many suggestions come out as in search engine, right? So it is one type of skimgram method. So why skipgram is important? It works well with small data set and infrequent words. Captures word relationships more efficiently than the SIBO, and widely used for training high quality word embedding in NLP applications. So Skipgram predicts surrounding basically Skipgram predicts surrounding words given a targeted word. It is used one hot encoding, a hidden layer, and a soft max output, and it is slower but more accurate than SIBO for learning word embedding. Right? I hope till here, like there is no doubt, right? Hello. Is there any more doubt till here? Okay. So the next thing after these two, what was? Can anyone tell me what was the limitation of word to vec? As I have said, just a single limitation. Okay, let me tell you. What was the single limitation due to which the RNN or and LSTM was introduced? It requires previous result. Okay. So basically, its limitation was it couldn't handle sentences meanings well. Okay. So excuse me, sorry. So uh, why? Just let me tell you that imagine you're reading a sentence I ate a. This is the sentence. I ate a dot 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 dot. The next word probably might be a burger, or probably might be chips, right? So what you did basically was to predict based on the previous words, right? Which was but earlier NLP models couldn't remember the past word effectively, like the SIBO and the skip gram model. It couldn't remember the past word, right? It just generates the word. But when it comes to RNN, the model can remember the previous word. Okay. So for an example, uh, difficulty in capturing long-term dependency. Yeah, that's the correct one. Okay. So the RNN, why it was used? Basically, it was used unlike the traditional NLP model. It was used to predict the previous word, like to predict based on the previous word. Okay. So can anyone tell me then why LSTM? Okay. Anyone tell me what is the full form of LSTM? Why LSTM was used or introduced, and what is the full form of LSTM? Long short-term memory. Okay, yeah, that's correct. So basically, RNN has two problems. Okay, it had two problems. That is, as the sentence get longer, older words are forgotten. Okay, and the second problem was sometimes the value grows too large, making the learning unstable. Okay, so to fix this, LSTM was introduced. So this is a network. You can say special gate that decide what to remember and what to forget. Okay, this helped NLP models understand long sentences better. Okay, so let me show you the diagrams. Wait a second. I hope my screen is visible to all, right? Guys, is it visible? Okay, okay. So can anyone tell me what is this? Like it looks a bit difficult, but it's very easy to understand. Okay, so this is a RNN. Okay, so I hope it's visible now clearly. So the green box. Okay, so the green box labeled as H represent the hidden state of RNN. Okay, so then the green circle labeled as X represent the input uh, at the step time, and the circle green circle which is labeled as L, it is represented as output. Okay, now U, W and V represent different weight in this network, and the loop inside the hidden state shows uh, how the edge that the network maintains information from the previous time step. So for for the instance, this pair shows the RNN. This pair shows the RNN expand over multiple time steps. Like it comes to this again, it goes over here, again it goes over here. Yeah. Okay. So here you can see H T1 with H T plus 1. Okay. So this is the previous one. This is the future one. It predicts over here. Okay, so each time steps allows, or we can say receive a new output such as x, xt, and generates an output as lt. Okay, here you can say here it is x t minus 1, here it is xt, here it is xt1. Like each output, sorry, each input gets different inputs over here, and it gets different outputs over here, right? So this structure allows the RNN to remember past information and use it to influence future predictions. Okay, so why is it useful? This is the core idea behind the sequence modeling. As someone said before, that what it does, it sequentiates. Okay, so uh, like it remembers the word or the sentences sequentially. Okay, so it's useful in applications like speech recognition, language modeling, time series for forecasting, and video processing. Unlike traditional neural networks, RNN can handle sequential data because they have memories of past inputs. I hope you understand this image, right? um, okay, so now let's talk about the next step, which is this one. This one is a LSTM model. So this also looks a bit difficult, but let me tell you how this how this works. So here you can see the input shelf to LSTM is okay. XT is the input at the current time step. Okay, here you can see XT, right? Okay, and HT1, T minus 1 is the hidden state from the previous time step, and C T minus 1 is the cell state from the previous time step. Okay, let me tell you like in basic ways. This one is input of current time step. This two, like this one is hidden state, and this one is the cell state from the previous time state. Okay, so LSTM uses three gates to regulate the flow. Okay, so it is 1, 2, and 3. It uses three gates to regulate the flow of information. So this FT is known as forget gate. Okay, determines how much the previous shell state should be forgotten. Like if I'm telling you paragraph, like I went over here and then I took a auto and went over there. I ate this, I ate that. So it will eliminate all the words that are unnecessary. Okay, and it will remember the words that are necessary. So it use a symbol as we can say sigma symbol or sigmoid or we can say activation function, which inputs value between 0, which is forget completely, and 1 for keep everything. So there are formulas uh, to this. I have mentioned in the notes. You can check once, and if you have any doubt, you can ask me over that. So next is the input gate, that is over here IT. Okay, so we decide what new information to add to the cell state. Okay, this is the cell state. Okay, so it decides what the information I need to add to the cell state. So it contains two steps. One is sigmoid layer and one is tanh layer. So it create so what tanh layer does, it creates new candidate values. Okay, and what sigmoid layer does, it decide which value to update, as I have told before. The next layer is TT layer. This layer, okay, it is a cell state update layer. So it creates new cell state and which is computed by combining the previous cell state, which is T minus 1, and the new candidate values. Okay. So the next state is the output state, which is OT. What it does, it controls what part of the update cell state should be passed to the hidden state, which is HT, H dash T, and then we can say this one over here. Yeah, and then what it does, it uses sigmoid layer and a tanh layer activation. Okay. Can anyone tell me what does tanh activation does? As I have told before, tanh is used to create new cells. Okay, we can say it creates new values. Okay, so CT is the cell state, HT is the hidden state, and gate. How many gates are there? There are three gates per gate: input and output. Okay, what it does, it controls the information flow to prevent long-term dependency from vanishing. So we use LSTM to overcome the vanishing gradient problem in standard RNN. And it can remember information for long sequences. It is useful in speech recognition, language modeling, and time series forecasting. So, okay, so let's talk about one more very interesting thing, that is BERT. Can anyone tell me what is BERT? Okay, so before BERT, we need to talk about transformers. Okay, can anyone tell me what is a transformer? I have told you in the first class and in the second class also. Hmm. Okay, so there are two things. One is attention mechanism and one is transformers. Have you ever heard about reading a long document but only focused on the important parts? That that is what attention mechanism do. Okay, instead of processing words one by one like RNN, uh, attention attention lets the model focus on the keywords in a sentence. Okay, somebody used for handling sequence. Okay, yeah. So, in what I have just told before, that instead of processing word one by one in RNN, it focus on the on the keywords in a sentence. So, for an example, we can say the animal didn't cross the street because it was too tired. So, what does it refers to? it refers to animal, right? So that's what attention mechanism helps AI model understand such relationships. This led to transformers, which process entire sentence at once and make them much faster than RNN. Transformers are now used in most modern NLP applications such as BERT and GPTs. Can anyone tell me what does transformer contains? Okay, so transformer contains two parts, encoder and decoder. Okay, I hope you remember that one. Let's talk about BERT. Can anyone tell me what is BERT? Guys, fast. So, BERT is basically known as bidirectional encoder representation from transformers. So, you can see read text in the BERT can read text from both directions, left to right and right to left. Okay, I repeat again, the BERT can like read from both directions, left to right and right to left. So it is used in Google search and question answering systems. Okay. For an example, if you give the sentence, the bank is near the river. The bird understand bank and refers to a location, not a financial instruction. Okay. Like it can read the bank is near the river again, and again it can read backwards. I hope you guys are understanding and over here. Let me share you the diagram of bird and all. Yeah, you can see here. Okay, so this is a bird basic one, and this is the bird large one. Let me explain. So, bird base contains around 12 encoder layers. So these are the encoder layers. Okay, so bird base contain how many? 12 encoder layers, and bird large contain 12 24 encoder layers. Okay, so these layers help BERT to process text by learning contextual relationship between words in a sentence bidirectionally, both left to right and right to left. So what are the key features? The first, like in this two, the first feature is the encoder layers are over here is 12 and over here is 24. The hidden size will be 76 over here, and here it will be 1024. Attention head over here will be 12 and 16, and total parameters this contain is 110 m and this one is 340 m. So why does this matters is bird base is smaller and faster, suitable for applications where computational efficiency is important. But why bird large matter? It is powerful but require more computes, making it ideal for high performance NLP tasks. Okay, let's talk about the next thing is GPT. Let me So this is a GPT architecture. Just a minute. Yeah, I hope it's visible. Yeah. So let me break down this. The input processing contains the model starts with input sequence like the text data. Okay, like over here, it provides the text data. Then input embedding happened. So words are converted into dense numerical vectors, or you can say 0 to 1. Okay. So next is positional encoding. So since the transformer does not process data sequentially like RNN, so positional encoding is added to retain words. or words order. So can like basically positional encoding means that it will remember the index, or it will remember how the words were placed in the sentence. The next thing is dropout. It helps prevent overfitting by randomly dropping some connection. Okay, as I have said before, what can anyone tell me what is overfitting? Just speak quick, right?
Noisy data with required data.
Sorry, what? Again?
Noisy data with required data.
Okay, that can be one answer. But when you try to give more input, okay, it what the model gets, it get overfitted. Okay, so from here to here, it is the input processing. Okay, so let's go to the transformer block stack. Okay, so here you can see the layer one. So, like each transformer consists of multi-head self attention, like MHSA. It is a multi-head self attention. Helps the model understanding relationship between words in the input. Use multiple attention heads to focus on different parts of the sentence. Masked attention ensured GPTs to predict words sequentially, unlike BERT, which looks at the entire sequence at once, but it like the GPT predicts the word sequentially. Okay, so this is basically used in softmax, dropout, and linear transformers. Then is the layer nomination. Uh, so this normalized the activation to stabilize training. And then next it's the feed, you can say feed network. Okay, feed forward network, which applies in two linear layers with a GELU, which is Gaussian error linear unit activation in between, and it helps model to learn complex pattern. And then is reducial connections, which helps gradient flow easily during back propagation, avoiding vanishing gradient issues. Okay, so the next part is we can say output generation. So what happens in output generation after passing through multiple transformer blocks, the model applies layer nomination, linear transformation, and softmax function. What happens in like linear transformation? To map hidden states to vocabulary size. Okay, and in softmax function, it generates probability for each words. I hope you understand till here. Okay, so the main thing is, what is the difference between GPT and BERT? So in GPT, we can say it learns from like it reads from left to right, but in BERT it is bidirectional. In GPT, it's based on text generation, and BERT is based on text understanding. In like in GPT, marks attention is there, but in BERT, no marks attention is there. Like BERT takes the whole sentence at a time, but in GPT it takes sequentially, right? Can anyone tell me what is the use case in GPT? Anyone can tell me what is the use case of GPT? Okay, so the use case of GPT can be chatbots, or we can say code generation. When it comes to BERT, it is sentiment analysis or Q&A analysis. Okay, so GPTs are important in like it is important for a lot of things like AI writing tools. It can generate human-like text by predicting the next word in the sequences, right? So, can anyone tell me for like just a basic knowledge? What is the version of GPT used in Chat GPT right now? 8. Okay. Anyone else? Oh, anyone else? Like how many are telling fifth? Like the 5 one? And how many are telling 4? Okay, 4. So basically, currently we are using GPT-4 Turbo. Okay, not 5, not 4. It is GPT-4 Turbo. Okay, so like let me do a small Q&A because we have very short time left. So why is Word 2 Vec better than one hot encoding? Anyone? Let me repeat once again. Why is Word 2 Vec better than one hot encoding? Guys, you can unmute yourself and tell there is no problem. Or you can just write over here. Okay, so what it does, it captures like the word to vec captures word meanings and relationship instead of treating words as a isolated symbols like one hot coding. And why did we move from RNN to transformers? Transformer process entire text at once, but and make it better and faster while handling hot sentences. Okay, so let's wrap up the session with like a practical implementation, which is write a Python program using Hugging Faces transformers to load a pre-trained word model and input a sentence and extract word embeddings from it. Okay, I have shared all the questions and all the assignments in the notes. I hope you do it, and we can conclude our session. Do you have any question, guys?
Madam, when you will explain project, weekly
Okay.
project?
Okay, so let me see. Next class, I'll explain the project. Okay,
Okay, ma'am.
and I hope everyone have done their assignments, right? So I will share like contact to my team to get all the assignments, and accordingly you will mark. Do you have any more doubts?
No, ma'am.
Okay.